want to have a look at a type of probability question that could come up. It's called conditional probability, and it's just about if a condition was kind of given prior to what we're trying to find out the probability of. So I may not have said it in a very straightforward way there, but I'm going to give plenty of examples here, hopefully, so that you do understand what I mean by a condition that might be in place. So let's just say I asked you, what are the chances that you might get a H1 in your Leaving Cert? So straight out, just asking, what's the probability of this happening? You know, maybe we might have to look up previous years' results to try and find maybe the relative frequency of what's been happening over the last number of years. So that's just straightforward probability question. However, now I'm going to just talk about, like, I'm your maths teacher, and like, what if I said to you, what are your chances of getting a H1 given the fact that I've never had a student get a H1? So there's a condition given in the question that does impact, like, you know, do you think that the fact that, and maybe, you know, we could argue that it doesn't, but it kind of feels like that condition might actually affect whether, you know, a student of mine gets a H1. So what if what if I change the condition? What if I said to you, oh, what are the chances of you getting a H1 given I've had many students get a H1? That condition that I'm talking about, whether, you know, I've never taught someone who's gotten a H1, or have taught someone who, you know, plenty who have a H1, those conditions might affect the probability of the student getting a H1. And this is what we need to look at when we're looking at a probability question. Is there a condition given? It's obvious enough as well, like, I could just be telling a story and giving you information, and the condition that I talk about may never impact the probability in the question. For example, what are the chances of you getting a H1 given that I have a dog? Not sure, that doesn't even matter. That condition does not impact the probability of one of my students getting a H1. So we're just reading in questions, and sometimes it'll be a straightforward probability question. Sometimes there'll be information in the question that might lead me to think, okay, there's a condition here, and that might be affecting the actual probability in the question as well. So we'll have a look at an example. The first example that we're going to have a look at, I'm going to show you the sample space. So this is actually in your book, and you can see the sample space in the book. As always, if you have the time to do a sample space, that is the most straightforward way to do a question in probability. It doesn't matter what type of probability it is. Having a sample space is brilliant. It allows me just to literally look at the sample space and count the favourable outcomes, count the total possible outcomes, and create my probability. So in a class there are 15 male students, so you can see it there, 5 of whom wear glasses, and 10 female students, again you can see it there, 3 of whom wear glasses. So they're just shortening M for male students, F for female students, and G for students who wear glasses. And the question that they ask, a student is picked from random from this class. What is the probability that the student is female given that the student wears glasses? So there's the condition. We want to know what's the probability that the student is female, and the condition that goes prior to that is, well, they wear glasses. So we can actually just count. So we're looking for the probability that it's someone who's female given that they wear glasses. So that little straight line there is given they wear glasses. So we need to pick out from our sample space all the people who wear glasses, because that's the condition. They have to be wearing glasses. So we look at our sample space. here with all the people picked out that wear glasses. And we have 3 students. 3 females out of the total possible 1, 2, 3, 4, 5, 6, 7, 8. So it's just 3/8. So if you have the sample space, it's great. It allows you to just literally pick out the samples, the people out of the sample space that wear glasses, etc. If you don't have a sample space, there's a formula that you could use, and I'll show you how to use it in that question as well, maybe. So let's talk about, we talked about F means they're female. I think M was their male. And G was they wear glasses. So what's the probability of the person being female given, that's a symbol for given, they wear glasses? And like I said, you could just, because we were looking in that situation, look at the sample space, but there's a formula. It's the number of people who are female intersecting with glasses. Like that just means, intersecting in Venn diagrams mean they're both. They're female and they wear glasses. So that's what I did. That's why I straight away, when I got my sample space of people who were wearing glasses, I literally started looking for female. So we're looking for females who wear glasses all over the number of people who wear glasses. And that's our formula. There's another version of it, but it's pretty much, it's pretty much very similar to that. It just talks about probability rather than the number of people who are female and wear glasses over the number of people who wear glasses. So when you see this formula, probability of A happening given that B has already happened, you're looking for the probability of A and B happening, so both happening where they intersect, all over the probability of B happening. This is where I already showed you here, Venn diagrams. So might want to go back over all our symbols from first year. I know it's ages ago, so your intersection symbol, union, cardinal number, complement, loads of these are in your log tables, so have a look back over them just to refresh, because you will see Venn diagram questions here. And even if we just look at one here, you can see that. Find the probability of X given that Y has already happened. So X given that Y has already happened is the probability of X intersecting Y, 0.2, all over the probability of Y, which is 0.3. Throw that into your calculator and you end up with 2/3. And then they do the probability of Y intersecting with X. So plenty of Venn diagram questions here in this section. Could have a look here at this one. So you're starting off and, we're just assuming it's I suppose we're in the probability chapter, so we're assuming it's a probability question. In a certain country, there are only 2 parties, the red party and the blue party. In the elections, 60% of the country votes red and 40% votes blue. So I'm just going to write this down here. So we have 60% vote red and 40% vote blue, and that makes sense. We have 100% altogether there. Of the red supporters, 70% favour disarmament. Now, that's not 70% of the country. It's 70% of the red supporters. So let's have a look at that. 70% of the red supporters, so 70% of 60%. That's 70% of 60%. What's equal to 42%? So 42% of the country favour discernment. Which means that 30% of red voters are not in favour of discernment. So let's just check that out so we have it as well. 30% of the 60% is 18%. Do not favour discernment. Okay? Can't spell that right. So what else does it say? Of the blue supporters, so not of the country, of the blue supporters, 10% favour discernment. Of 40% favour disarmer. Again, 10% of 40%. That's 4% favour disarmer. Discernment, sorry. And these are the red. And these are the blue. And then that means 10% of 40%. So 90% of 40% do not favour it. 90% of 40%. Again, you could probably do this in your head. It's 36% do not favour discernment. And this is all the information that we have here. A voter is chosen at random and announces that she favours discernment. So there's a condition. You have a voter who is chosen at random. She favours discernment. What is the probability that she's a blue support? She supports the blue party. Well, can you see there that there's a condition given? What is the probability that she supports the blue party given that she favours discernment? So I'm looking at what's the probability that she favours the blue party. You know, she supports the blue party given that she favours discernment. So let's say wants discernment. So my condition means that I can use my conditional probability formula. I don't have a sample space here. So it's the probability of being a blue supporter and favouring discernment all over the probability of favouring discernment. So what are the chances that you have a blue supporter who favours discernment, so that's 4% of the country, all over the people who favour discernment? So it's 42% who favour discernment of the reds of the country and 4% here. So we have 42 and 4 is 46%. Throw that into the calculator. And we have 2 over 23. That are the chances that they're a blue supporter given that they favour discernment.